Hello. So in this video we're going to be dealing with indirect proofs, and we're going to be introducing just the basic mechanics, not just for indirect proofs but also for conditional proofs. This one is going to do it through the indirect proof, and then I'll make another video for the conditional proof. So this is kind of like part one of two. The indirect proofs, I should say that this video presumes that you can do arguments and proofs that include all of the 18 rules, the rules of inference and the rules of replacement. So I'm not going to spend a lot of time explaining those. I'm just going to focus on the indirect proofs. So what an indirect proof does is it allows you a different way of proving an argument. I'm going to say it once and then we'll demonstrate it. So remember that for a regular argument, what we're always saying is that if premise 1 is true, and if premise 2 is true, or if all of the premises are true, the conclusion is necessarily true. This conclusion must be true every time the premises are true. So it would be impossible for that to be true if the premises are true. That's not a possibility. There's no wiggle room about it. In other words, the negation of the conclusion. So if the conclusion was something longer like C and N, if that was our conclusion, then this would be the opposite of the conclusion. Not this, but this. Okay. So in our indirect proofs, this is what we do. A regular direct proof, which is what we've been doing before, to just highlight what that means, it means we go step by step, using one rule at a time, referencing premises that we have established as being true, until we get to our conclusion. An indirect proof and the conditional proof allows you to make an assumption within the argument. In other words, you can put something on the line here that isn't necessarily true, and in fact might very well be false. The way we do that is this. So we sort of indent our line. We don't have to write anything on our paper, but we have a tab, a few spaces worth, and then we draw a single vertical line. And this line will go down so long as we are in the assumption. So what do I mean by when we're in the assumption? So for step 3, instead of using a rule on steps 1 and 2, I'm simply going to assume not N. So I have my indentation and I write not N, and I'm going to write A, I, P, which stands for an assumption through indirect proof. I'm not saying this is true. All I am saying is that it might be true, or I'm not even saying that. I'm saying that for the sake of argument, we're going to assume this is true, and let's see what happens when it is. So as I move through the argument, I can keep building off of not N. So I will continue drawing this line down, and I will say, all right, if I know that not N is true, then I can still build off of these premises because I know these premises are true. They're true. These are established within the world of my argument. So I can use this as if it were an established premise. And if this were an established premise, then you can see line 2, where the consequent is N. And step 3, we are denying that consequent. In other words, we should be able to see how modus tollens could work here if not N were true. And if modus tollens is the rule we use, then we would deny our antecedent, which will be not R or M. And then we simply write, just like we would before, 2, 3 modus ponens. I'm sorry, not modus ponens, modus tollens. Okay. Now, before we continue on, I just want to say one thing that we cannot do. We cannot come back down here and establish, for example, not R and not M from 4 De Morgans. if we were in an argument, so let's go over here. If we were in an argument and we had step 1, not R or M, okay, then it would be legitimate to use De Morgan's and say not R and not M. That would be a legitimate use of De Morgan's. But what we're doing here is we're saying we know this is true. And we say that because of that number 1, we know this is true. Number 2 follows from number 1. The problem with doing it over here is that we're claiming when we put it outside of that line, when we put this statement, not R and not M, when we have it standing outside of our land of assumptions, we're declaring this to be true. We just don't know that it's true, though. So there's no way you can leave the world of assumptions anytime you want to. There's special occasions when to leave the world of assumptions behind safely. So let me show you what I mean. So just like I said you couldn't use De Morgan's out here on number 5, you can use De Morgan's here. So we're going to use De Morgan's, not R and not M, because in the world of assumption, if this were true, then this would be true. So we're going to write, let me get rid of these little dots here. We're going to write 4 De Morgan's. I am getting used to this new pen. My handwriting is awful. It's strange to be writing on one surface and seeing it appear on another. Hopefully my handwriting will get better. Anyway, so now we have not R and not M. What else can we do? So look at premise 1. Well, by now you should know this. We can see not R. Not R. We have this from 5. Simplification. See how bad that handwriting is? Okay. And if we have not R, then we can deny the antecedent from premise 1. This gives us not K, therefore K. So we can keep doing this. 1, 6, modus tollens. So by now you're probably asking, all right, I think I get what we're doing. What am I aiming at? And what we're aiming at is a contradiction of sorts. Not just of sorts, we're aiming for a straight up contradiction. What we're trying to prove is this, that if our conclusion is false, that will lead to an absurdity. In other words, it will lead to a statement that is internally contradictory, that cannot possibly be true. So something like not A and A is what we want on this line. And if we find a line that says something like not A and A, that's not possible, because we're saying that A is both true and false. And at least in our truth functional language, we can never have that happen unless the argument gives it to us, and that's weird. That's a different story. So we're going to keep working until we find 2 of these letters that contradict each other, or one of the letters that contradict itself. Okay, so we're going to move on, and at this point we can say, let's do implication, the rule of implication on if K then K. Not K or K. That is from 7, implication. Now let's use De Morgan's. So this is not K and not K. Look at that. There we go. So that's 8 De Morgan's. Okay. Now look at this. This is not K and not K. Now this is actually, I've said in class that if you really wanted to be a stickler for rules, you should probably use double negation. But actually this isn't, even if we are a stickler for rules, this is enough for our purposes, because not K and not K is still of the form not P and P. It still has the form we're looking at. One denies the other. So this is a contradiction. We're saying that K is both not true and not true, or just to say it more easily, K is both true and false. But that's impossible. This cannot happen, which means that whatever we assumed that got us there cannot possibly be true. Okay, so this is interesting, and this is basically the heart of what these assumptions are all about. Even though we assumed something for which we had no logical reason to know, we've learned that if we assume not n, it necessarily leads us to an impossible situation. If it leads us to an impossible situation necessarily, then the thing that led us there must also be false. Some of these might be true in the middle here for various reasons. They might be built off of the premises, or they just might be accidentally true. But this statement that started it all off must necessarily be false if it led to a contradiction. Since we know not n is false, then we can assert n is true. And then we simply write, we know this from steps 3 through 9 via the indirect proof. And that's how you do an indirect proof argument. So in the next video, we'll be looking at conditional proofs.